Hi everybody. So in this video, we're going to talk about section 3.4, which is on completing the square. Okay, so this is another method for solving quadratic equations. We already saw extraction of roots and solving by factoring. Okay, so this is our third method. This method is also going to be useful later on for something else. So just keep in mind, in case this isn't your favorite method for solving, its real utility lies later on when we talk about vertex. Okay, so let's talk about how you do this method because this is something that you may not have seen before. Okay, so the first step is to put your equation in standard form. Okay, and this is the ax squared plus bx plus c equals 0 form. Okay, then the second thing we're going to do is group the terms. Okay, so if we have this leading coefficient, we're going to factor it out of the first two terms, okay? And then we're going to leave the constant term alone, actually, okay? Then we are going to find b over 2a, okay? And then we are going to square it. Okay. All right. After we do this, we're going to add and subtract this value. Okay. And then we are going to factor into a square. Okay. And then we are going to finish solving using extraction of roots. Okay, so the first 6 steps are really the ones that are the completing the square method, okay? And then after that, you have a completed square and you can solve that using extraction of roots, okay? So this is how you solve using complete the square, but it's really the first 6 steps that are the complete the square part, okay? So let's look at some examples. Okay. Okay, so the directions say solve by completing the square. Okay, and then we're going to do that for some different equations. Okay, so we're going to start with some equations where it's really easy to complete the square. Okay, and I know that you could certainly solve this by factoring. Okay, but we're going to solve it by complete the square, and then later we'll do some examples of problems that you can only solve using complete the square method. Okay. All right, so we're going to start by grouping the terms together. Now this is kind of silly for this example because there's not even a constant term. Okay, and there's nothing to factor out in the front. Okay, so now I'm going to find that value that we talked about. So you're going to take 8 and divide it by 2. Okay, and then you're going to square it. So 8 divided by 2 is 4, and 4 squared is 16. Okay. So now in this example, I'm going to both add and subtract 16. Okay, so inside the parentheses, I'm going to add 16. Okay, I'm actually going to, and then outside the parentheses, I'm going to subtract 16. Okay. Now the stuff inside the parentheses should factor now. Okay. So we're asking what multiplies to 16 and adds to 8. So it should be 4 and 4. Okay, and this minus 16 is just going to get carried down here. Okay, and I'm actually going to rewrite this with the square notation like this. Okay. All right. So this is the part that I would consider completing the square up to this point. Okay, so now we're going to finish up our solving by using extraction of roots. Okay, so when we extract roots, you know that we want to isolate the square part, which is here. So we're going to add 16 to both sides. Okay, then we're going to square root both sides. And we're not going to forget about the plus or minus. Okay, so this leaves me with x plus 4 equals plus or minus 4. Okay, and just to get the two values of this, I am going to split this up. So x plus 4 equals 4, or x plus 4 equals negative 4. Okay, so this gives me x equals 0, and this gives me x equals negative 8. Okay, so there's my two solutions. Okay, so the part that's in blue is the part that I would consider complete the square. Okay, and then this part is the extraction of roots method that we learned last time. Okay, all right, let's do another example of that. Okay, so we're still going to be solving by completing the square. Okay, same directions as last time. We're just going to do it with a different polynomial. Okay. All right, so the first thing I'm going to do is group the terms. Okay. There's nothing to factor out here, so that's why I'm not factoring anything out. I'm going to group my first two terms together. Okay, and then I'm going to leave my minus 5 out here. Okay. And then I'm going to figure out what number I need to add in here. Okay, so I'm going to take my coefficient of x, which is 4. I'm going to divide it by 2. Okay, and then I'm going to square that. Okay, so 4 divided by 2 is 2. Okay, 2 squared is 4. Okay, so I'm going to be adding 4. Okay, and then I'm going to be subtracting 4. Okay. All right. So again, I'm going to factor this. Okay. Now we know it's going to factor into a square. It should always. That is the point of completing the square. Okay. So we're saying what multiplies to 4 and adds to 4? It's 2 and 2. So this is going to be x plus 2 squared. Okay. And then we're going to combine these. Negative 5 minus 4 is negative 9. Okay. And you can see that this is our completed square, right? So you know that you've completed the square when you have this square part. Okay. So now I'm going to do extraction of roots to finish up the problem. So I'm going to isolate my square by adding 9 to both sides. Okay. Then I'm going to square root both sides, not forgetting about my plus or minus. So this gives me x plus 2 equals plus or minus 3. Okay, and again, I'm going to split this up to get my two solutions. Okay, so this gives me x equals 1, and this gives me x equals -5. Okay. All right. Let's look at another example. Okay. Now the previous two examples could have been solved using factoring. Okay, so if you go back and try those examples, you can see that you would be able to solve those two by factoring, but this one is actually not something that you can solve using factoring. Okay, so the first thing we're going to do is group our terms. Okay, and then we're going to figure out what we need to add. So we're going to take our coefficient of x, which is 6, and divide it by 2. Okay, and then we're going to square it. Okay, so we're going to be adding 9, and then we're going to be subtracting 9. Okay, now we're adding it and subtracting it, right, because we don't want to change our original equation. Okay, but we need this 9 in order to make this a perfect square. So that's kind of the aim of the method. You're adding what you need to make this a square, okay? But in order to not change it, you also have to subtract this number. It's just like when you want to multiply something by 2 and you have to do it on both the top and the bottom. Okay, this is that same idea. You want to add 9 to make this a square, but you have to also subtract it so that you're not changing the problem. Okay. All right, so now we're going to factor this. We're asking what multiplies to 9 and adds to 6, so it's going to be 3 and 3. Okay, and then we're going to combine these two together. So 2 minus 9 is -7. Okay, and now that we have our completed square, we're going to solve this by using extraction of roots. So I'm going to add 7 to both sides. Okay, then I'm going to take the square root. Okay, so this side will have x plus 3. Okay, now over here, the square root of 7 doesn't come out evenly, so I'm just going to leave it as the square root of 7. Okay, and now I'm going to subtract 3 from both sides. Okay. Now, I just want to point out that like we talked about in the previous example, we are getting that our two solutions are radical conjugates. Okay, so you can see that pair of answers where the whole number part is the same and the square root part is opposite. Okay, just like we talked about in the previous section. Okay. Let's do one more example like this, and then we'll move on to a different type of example. Okay. So we're going to start the same way. We're going to group our terms. Okay, and then we're going to decide what number we need to add. So we're going to take our coefficient of x, which is 5. Okay, and I'm going to divide it by 2, and then I'm going to square it. Okay, now 5 doesn't divide evenly by 2, so I'm just going to square this top and bottom. Okay, so this is my number that I need to add, so I'm going to add 25 over 4. Okay, and I'm going to subtract 25 over 4. Okay, same as before, but now we have a fraction. Okay, now this is where things get a little bit tricky. Okay, now it's hard to tell how this is going to be factoring, right? Because normally we would say what multiplies to this and adds to this. Okay, now I want you to think about our previous examples. Okay, and let's look at the pattern of how these actually factor. Okay, so this is the previous example. You can see that the factored number is actually right here. Let's look at part B. Here's my factored number. Same. Okay, let's look at part A. Here's my factored number. There it is. Okay, so you can see the pattern, okay, that the number that appears in the factors is actually going to be this one. Okay, so we're going to see that number here in our factors. Okay, that's always the case. It's not always important because normally you can factor it by hand, but when you have these fraction situations, it is important to remember that this is the number that appears in your factors. Okay, and then I'm going to combine these two by making like terms, right? Common denominators. Okay, so 20 over 1 is going to be the same as 80 over 4. Okay, so negative 80 minus 25 is going to be negative 105 over 4. Okay, so now we have our completed square, and we're going to solve using extraction of roots. So I'm going to isolate my square by adding 105 over 4 to both sides. Okay, and then I'm going to take the square root of both sides. Okay, so over here I'm going to get x plus 5 over 2. Okay, now over here the square root of 105 isn't something that I know the answer to, but I do know that the square root of 4 is 2. Okay, and I'm going to finish this problem by subtracting 5/2 from both sides. Okay, now you can leave your answer like this, or you could rewrite this, right? These have common denominators already, so it is certainly possible to write this as a single fraction, right, with the common denominator 2. Okay, I also wanted to point out that these two solutions are also radical conjugates, right? Same real part and then opposite rational part. Okay, all right. So those 4 examples all had one thing in common, and it was that the leading coefficient was 1. Okay, so let's see some examples where the leading coefficient is not 1. Okay, so we'll look at this one first. Okay, so now when I go to group my terms, okay, this is the main part that's different. I'm going to factor this leading coefficient out. So I'm going to have 2 times x squared plus, when I factored the 2 out here, I'm going to have 4x. Okay, and I'm going to leave my plus 1 totally alone. Okay, because it's outside the parentheses, I don't need to factor out the 2. Okay, and now I'm going to decide what number should go in here. Okay, so I'm going to take my coefficient of x, which is 4, I'm going to divide it by 2, and then I'm going to square it. Okay, so this would be 2 squared, which is 4. Okay. Now, in case we couldn't figure it out, this is the number that was going to appear in our factors, remember? Okay, but this is the number that we are adding and subtracting. So we're going to add 4 here. Okay, and now we have to imagine what's going to happen if we were to multiply this back out. Okay, so right now, we're just going to take a little break and we're going to imagine what would happen. Right? So we would have 2 times x squared. Okay, then we would have 2 times 4x. Okay, and that's great because that lines up with our original problem. Okay, now what would happen here? 2 times 4 is 8. Okay, and then we have that plus 1. Okay, so because of this 2, we've really added 8. Okay, so what we want to do is subtract 8. Okay, so we added 8 and we're subtracting 8. Okay, so we're going to go back to the main part of our problem. Okay, so we're going to factor the stuff in parentheses. So what multiplies to 4 and adds to 4, it's going to be 2 and 2. Okay, 1 minus 8 is negative 7. Okay, and that's how we've completed our square. Okay, all right. So let's finish this up by extraction of roots. So I'm going to add 7 to both sides. Okay, and then I'm going to divide both sides by 2. Okay, now I'm going to square root both sides. Okay, so over here I get x plus 2. Okay, and over here you can't simplify this at all because 7 isn't a perfect square, but neither is 2. Okay, and now we're going to subtract 2 from both sides. Okay, and now you can see that radical conjugate pair where we have negative 2, and then we have plus 7 over 2 or minus 7 over 2. Okay, all right, let's do another example like that. Okay, so the first thing I'm going to do is group my first 2 terms and factor out that leading coefficient. So I'll have x squared plus 2x. Okay, and remember you're leaving that third term completely alone here. Okay, so now I'm going to decide what I need to add. So I take my coefficient of x, which is 2. I'm going to divide it by 2, and I'm going to square it. Okay, so I'll have 1 squared, which is 1. Okay, so I'm adding 1 here. Okay, and again, we're going to imagine what would happen if we were to distribute this, right? If we did 3 times 1, that would be 3. So I'm going to subtract 3 here. Okay, so this answer is how I'm getting that number. Okay, 3 times 1, and then I subtract that number here. Okay, now I'm going to factor this. So what multiplies to 1 and adds to 2, it's a 1 and 1. Okay, and then negative 2 minus 3 is negative 5. Okay, so I've completed my square. Here you can see the square part. And now I'm going to finish this by extraction of roots. So I'm going to add 5 to both sides. Okay, divide by 3. Okay, now I'm going to square root both sides. Okay, on the left this simplifies to x plus 1. Okay, and on the right, okay, this doesn't simplify at all, so I'm just going to leave it. Okay, now I'm going to subtract 1 from both sides. Okay, and there's my pair of answers. -1 plus root 5 over 3, -1 minus root 5 over 3. And you'll notice again that they are radical conjugates. Okay, we're going to do a couple more examples with these leading coefficients because I think this is the trickiest type of example. Let's rewrite this. Okay. All right. So the first thing we're going to do is group our first two terms, and we're going to factor out this -2. So we'll have -2 times x squared minus 2x. Okay, and remember, we're leaving that 5 completely alone. Okay, so now I'm going to take this number, my coefficient for x, I'm going to divide it by 2, and I'm going to square it. Okay, so I'll have -1 squared, okay, which is 1. Okay, so I'm going to add 1. Okay, and I'm going to imagine here, okay, I have -2 times 1, that's -2. Okay, so I'm going to put the opposite number here, and I'm going to do plus 2. Okay. All right, so let's factor. Okay, so what adds to 1, or what multiplies to 1 and adds to -2, it's going to be -1 and -1, so we'll have -1 squared. You can see that that lines up with this number. Okay, and 5 plus 2 is 7. Okay. So now that I have my completed square, okay, I'm going to go ahead and complete this by using extraction of roots. So I'm going to subtract 7 from both sides. Oops, x minus 1. Okay, then I'm going to divide by -2. Okay, square root both sides. Okay, this is going to give me x minus 1. Okay, and over here this doesn't simplify at all, right? Neither of these are squares, so I'm just going to leave it like this. Okay, and now I'm going to add 1 to both sides. Okay, and that would be my pair of answers. 1 plus root 7 over 2, 1 minus root 7 over 2. Okay. All right, let's do one more example with the leading coefficient. Okay, So the first thing we're going to do is group together our first two terms and factor out that 4. So I'll get x squared minus 4x. Okay. My plus 3 is just out here. Okay. And then I'm going to decide what number needs to go here. So I'm taking my coefficient of x, which is -4. Okay, I'm dividing it by 2, and I'm squaring it. Okay, so I would get -2 squared, which is 4. So I'm going to put plus 4. Okay. Now here I would get 4 times 4, which is 16. Okay, and I'm going to put the opposite number here, right? So -16. Right, so this one's positive 16. You do the opposite, -16. Okay. So now I'm going to factor this. So we're saying what multiplies to 4 and adds to -4, so that should be -2 and -2. Okay, and then 3 minus 16 is -13. Okay, so here's my completed square. Okay, and I'm going to go ahead and finish this using extraction of roots. So I'm going to add 13 to both sides, and then divide both sides by 4. Okay, now I'm going to take the square root of both sides. Okay, so this side is going to simplify to x minus 2, and this side I'm going to get plus or minus. 13 isn't a square, but 4 is, so I'll get root 13 over 2. Okay, and now I'm going to add 2 to both sides. Okay, so there would be my two answers, 2 plus square root of 13 over 2, or 2 minus square root of 13 over 2. Okay, all right. I know this can be a difficult topic, especially with the leading coefficient not being 1. Okay, so I really encourage you guys to practice this, and I will see you guys soon.